All right, thank you for joining us. If you're already with us, I think we're waiting on a few more people to log in. So as those people are logging in, I'll go ahead and do just a brief introduction. So if you're having any trouble hearing us, or if you have any questions throughout the presentation, please feel free to pop those into the questions box at the top of your screen, and we'll answer those towards the end. So good afternoon or good morning, depending on where you're joining us from, and thank you for attending our webinar today. My name is Ellen, and I'm a technical sales specialist at BPES, focusing on our cell line development portfolio. BPES are the UK distributors of scientific instruments, process equipment, and consumables, and we're proud to work with a number of brilliant suppliers across the world, including SYNENTEC. Based in Germany, SYNENTEC is a leader in the field of automated imaging systems and provides the latest standard in image acquisition, device controlling, and image and data analysis software. So today we are really excited to share with you an introduction to SYNENTEC's latest development. So I'd like to introduce Ben Wertelman, who is the Director of Business Development and Applications at SYNENTEC. Over to you, Ben.
Thanks for the kind introduction, Ellen. As we probably have told everybody by the announcement of this webinar today, I'll be talking about YT Reports, SYNENTEC's latest product made for the high throughput imaging systems NI1 and CellaVista. And a lot of our customers use NI1, use CellaVista and CellaVista 4 for the image-based proof monoclonality. And they do that in order to fulfill ICH Q5D, which requires that biologics production cell lines need to be cloned of a single cell originator, single cell progenitor. And an easy way to assure and to prove monoclonality is taking images of single cells in microtubular and our systems, due to their high throughput, really lend themselves to depict one single cell in a high resolution needed for doublet discrimination, because FDA, EMEA, or other regulatory bodies require a well-lit full well image for the proof of monoclonality. The assurance of monoclonality, on the other hand, which has been thrown around in the literature quite often, is something different, and we'll be talking about this later. What is not a valid proof of monoclonality, e.g. not a single cell full well image that is well lit, is something we can see here in our clone gallery, which are exported into these nice overviews film strips, which provide a seamless documentation and clear images in a comprehensive visualization, but they are not a full well image, so not really relevant for proving monoclonality. It's good to have, but it's not required. What definitely is required is the assurance of monoclonality that is used to provide statistical data on process validation studies that are very, very easily done with distinguishable cell studies, as outlined in recent BPDG papers mentioned in the bottom of the slide. But this latest industry standard that is used to ensure the highest probabilities of monoclonalities is using co-cultivated GFP and cherry or other fluorophore labeled cells. After co-cultivation, they are subjected to single-cell cloning with the process of choice and are subjected to 3-channel imaging in bright field, in the one and in the other fluorescent channel, which is GFP and cherry in this example. And this enables looking into the process efficiency and process accuracy of generating meaningful data for the proof of monoclonality. And a study like this not only enables people to generate data on ghost well probabilities, but also on false clonal well probabilities, where there basically is a ghost well above a clonal well, so to speak, and that is visible in a single cell depicted on seeding day, outgrowing into a colony of a mixed color, as you can see on the right-hand side. And this is from the non-centrifuged group of this very case study that has been kindly provided by a customer. Having that said, the proof of monoclonality in principle is very easily done, but the problem oftentimes, especially in 96 well plates, is this one. You have a lot of data and a lot of pixel ground to cover for an object that is really, really small compared to the full image size, because it needs to be full well in the 96 or 384 or whatever well plate format. So we've had various customers with negative experiences in this field by either having monoclonal origin disputed by FDA because Microsoft Word's resolution for a full well-lit image of a 96 well plate was too low and visible anymore, or another customer who in their imaging core has to create a multi-page image export manual for the project leads, to ultimately be able to do the image handling for the BLA appendices. So in order to comply with ICH Q5D and provide the image-based proof monoclonality, having in mind that our imagers provide a higher resolution than ever before with the 4K line of instruments, and that only 0.0006% of 96 well plates area is covered by a single cell, we have generated YT reports that supports the native 4K resolutions found in our latest products, but also all the legacy products like the SYNENTEC line of instruments or the CLD line of instruments. And the resolution within the PDF can be customized up to 270 megapixel and provides a ready-to-use PDF with even your company's logo in a customization section, and is done in a very, very fast and easy workflow. To load an experiments within YT reports, I just have to click the plus button and then select the experiment, just like known from YT. And then I have the classical interface that I am able to navigate with the mouse wheel and the mouse cursor by clicking and dragging the images around. I can also influence the channel visualization very easily, and also I can switch between different time points in the experiment and activate them later on too. At this stage in the process, I already know what well I'm interested in, so I can select the well right here and also tag it as a monoclonal well if I want to. And then I can take care of the general settings, which is not influenceable, is the experimental name as in form of a barcode right here in this example. But I can put in the project name of my molecule or cure or project identifier, put in the authors, take care of well padding, and select the full well image size. And if I want to include the annotation-free full well image. For the proof of monoclonality, it is oftentimes required that two independent trained users confirm single cell origin of a given clonal cell line, and we've accounted for that by including the raw data review section with the first, second reviewer, and the internal reviewer too, which would be basically the manager overseeing that the SOP was followed to 100% and no deviations had occurred. I can import external media like the clone galleries we are generating with YT or any other data that I need incorporated into my YT report. And also I can change the channel visualization within this program. Here in the app settings, I can select the company name I'm working for and the logo I want to include in the report. And after all of this is taken care of, I can zoom into the single cell well, find the single cell, also check if it really outgrew into a colony or not, and can go into the annotation section, select the annotation type cell, hold Control, and also change the annotation size if I want to, and click to create the annotation for this very well. I can just call it single cell and keep it like this. I can set up multiple classes with artifacts or debris. I can label if I want to. So I have a very comprehensive report that outlines not only the single cell, but also artifacts or debris that may be mistaken for a single cell. To start the report generation, I just have to click the play button in the bottom and generate the report PDF that is automatically opened with the default PDF program. So I can immediately inspect the PDF quality and the layout. This is the first page with relevant metadata generated by the experiment or by the user when generating the raw data. It also contains the raw data review section that says the trained users independently reviewed the raw images for single cell presence and hereby confirm the monoclonality of the cell line generated. It also pulls some of the experiment settings in terms of focusing, image processing, or imaging parameters from the experiments to also include something like the pixel size or resolution. Next page would be the external media, in our case the clone gallery that I've imported, and then the different annotated or unannotated well images would be shown. In this case, the customer had empty well images taken prior to CL seeding to make sure that all the artifacts or debris or media components that could be mistaken for a cell are present in the images too. And the different time points in the top are actually clickable. So navigation through the different time points is really, really quickly done. And the different single cells or the different artifacts and debris crops can be inspected very, very easily by just using a PDF viewer, and would not require any of the SYNENTEC products for high resolution viewing. If I zoom into the program, into the image right here, I can also see the single cell really, really nicely across the different time points. As I mentioned, all metadata is provided at a glance, including the annotation-free full well image. The timelines are easily generated and active, and fully traceable annotations with individual numbering are generated very, very quickly. If you have any questions about YT reports or about the SYNENTEC imaging systems, Dr. Alex Gouladani will be happy to.
Great, thank you so much, Ben. That's a great introduction to YT reports. So if you didn't hear me in the beginning, if you have any questions, please feel free to drop those into the questions box at the top of your screen. It looks like we've had a few come in. So I will read these out for Alex, who's going to be answering the questions for us today. Let's see, so it looks like the first one is dealing with the YT audit software. For those of you who don't know, SYNENTEC offers a CFR 21 Part 11 compliant version of their software called YT Audit. So the question is it possible to use YT reports for audit experiments alongside YT Audit? Alex, if you can hear me, I think you might be muted.
Hello, do you hear me now, Ellen? Hi.
Yep, I can hear you. Perfect.
Yeah, thanks everybody, and thank you for question. Yes, so it can be used alongside YT audit, and YT audited experiments can be also loaded, and you can also generate same kind of reports with that audited experiments too.
Great, thank you. I'll go to the next one here. So this is, what is the licensing? It's a two-part question. What is the licensing model for YT reports? And can one license on a single PC be shared with multiple imagers?
So the licensing, yes. So the second part of the question, yes, it can be shared, and it's an yearly license which will be renewed every year, and it's a part of the software service agreement. Would be a part of the software service agreement, exactly. Yeah. Yeah.
Thanks, Alex. Let me see, another one has come in. Are there any special PC requirements for running YT reports?
I think basically you need to have a updated PC. Windows 11 would be great, and also Windows 10. And you can also run it on the laptop. That's also possible, which I did myself. And yeah, so it has to be up to date, basically.
Okay, perfect. Let's see, we've got another one. So this is a good question. What about the other applications besides single cell cloning? So SYNENTEC's imagers are preloaded with, I think it's 84 plus applications,
Yeah.
not to mention the ones that are still being developed. So can YT reports be used with those as well?
Yes. So you can also do any other application, such as, for example, high content screen with different fluorescence channels, and for example, viewing some organelles or some kind of nuclei assay. And you can exactly do the same annotations with in the different channels and in different measurements, so to say. So yes, it's enabled for every application that's on board on the system. And depending on if you have fluorescence or not, you can use these applications accordingly.
Brilliant. Okay. I have a follow-up question to that. Obviously, in Ben's demonstration, it was quite quick to generate a report for monoclonality. Would you say that the time it takes to generate reports for other YT experiments is comparable to that, or maybe depending on the
Yeah,
customization, it takes a little bit longer?
not at all. So it's basically if you have if you can run these reports on single cell cloning application, it's basically the same for all the applications that are enabled. So yeah, so the times are pretty similar to each other. It's not dependent, really depend on the application. What it depends, it's like if you include a lot of images into the applications, it might take a little bit more time, and then you need to have a really yeah, so updated PC, as I said, PC or laptop, and yeah, like at least maybe 16 gigabytes of RAM if you have really high throughput data generation and you want to do it really fast. So, but actually, what Ben did took, I think, 20 seconds, and it
Yeah,
was also
really
a lot of
fast.
data. Yeah, so yeah, we are talking about like under 1 minute anyway.
Brilliant. Okay. Looks like we've got one more question that's just come in. Is it possible to include multiple experiments within one report?
Oh, that's a good one. Not multiple measurements, but multiple experiments.
Yes, that's right.
Yeah. No, it's not.
Okay.
Because yeah, it's at the moment it's not, but I can yeah, I can bring it up for our software developers. And they are pretty quick in implementing this kind of stuff. So it could be, I think we could enable it too. Yeah.
Good question. So then are multiple measurements are possible?
Yeah, absolutely.
Okay.
So that's day 0, day 5, day 7, for example. That would be multiple measurements of one experiment. And yes, this is absolutely enabled because you need it also for the single cell cloning at the end of the basically measurement. You need to have the colony, or you would like to have the colony, and yeah, that's why we absolutely enable this.
Okay, perfect. It looks like that is all the questions that we've had come in. If anyone has any others, please feel free to either submit those questions now or please do contact us. You can contact us at either info@bpes.co.uk or if you'd like to contact SYNENTEC, it's info@synentec.com. So thank you so much, Ben, and thank you, Alex, for answering questions.
You're welcome.
Hopefully everyone, yes, it was a good session. Hopefully everyone has had a good overview and a good understanding of YT reports. It's a great solution. So again, if anyone has questions, please feel free to follow up with us, and we will be sending out a recording of this webinar, I think in a week's time. So thank you so much for attending, and enjoy the rest of your afternoon.
Thanks a lot. Thank you, Ellen, and bye-bye.
Thanks, Alex. Bye.